Hello and welcome to today's video on halfway rectification. In the previous video, we talked about how to obtain the halfway rectification, the waveform of the halfway rectification. So if you want to understand how we got the output waveform, or we got the voltage across the load resistor, you can pause here and then go and watch that video on that. So today's video, we are going to talk about how to calculate average voltage of the output voltage that we have, right? And the output voltage here was the voltage across the load resistor. So we have the voltage across the load resistor, and based on that, we got this signal. So we are going to indicate this. Right, so we have the signal, and we sketch for 3 cycles of what the waveform. So let's say we start with 0 to pi. I have my pi here. Then we have 2 pi. We have 3 pi, 4 pi, 5 pi, and then what? 6 pi. So we have this. Now, so when we talk about halfway rectification, meaning you can think about this way, meaning you have, for example, a full cycle or a cycle that you have, then it's being passed through a diode, and as a result of that, you only get half of that cycle. So from 0 to pi, we tend to have the maximum voltage. So I can indicate here as my maximum voltage is here. So we have something of this nature. Okay. Then we have 0 to pi to 2 pi will be 0. So we have this as 0. Then from 2 pi to 3 pi, we have another. So we have another alternation. From 3 pi to 4 pi, we get 0. Then from here to here, then the last one you can see, so 5 pi to 6 pi will be 0. So we have this kind of waveform, right? Now, how do we calculate the average voltage? So to calculate the average voltage, we start with the formula for calculating the average voltage, and the formula is that average voltage is going to be equals to area under the curve over horizontal distance, right? So each of this, we have to try and then understand what each of this means, and then based on that, we can calculate the average voltage. So let's start with area under the curve. So area under the curve here, it means that we are going to look at our rectified signal. Let's say for what? From 0 to what? 2 pi. So we have 0 to 2 pi. Now from 0 to 2 pi, you can see that from 0 to pi, we have what? An alternation, right? Positive alternation. And then 0 to pi to 2 pi, we just have 0. So within this range, 0 to 2 pi, you can see that we have this alternation. So the area under that's what we mean by area under the curve. So you can see here is a curve, the alternation here is a curve. So the area within that's what we refer to as the area under the curve. Now that we know this, let's move on to the horizontal distance. So horizontal distance here is going to be the distance from 0 to 2 pi. So means the distance within which we are trying to look at the length or the length of what the alternation waveform that we are, or the length of what the signal, right? Or you can look at it in terms of what is going to be what the same as the 2 pi. Why? Because 2 pi here is the same as in radians is the same as what a full circle. So when we talk about horizontal distance, since we are trying to look at the waveform within 0 to 2 pi, meaning within a circle, so our horizontal distance here, I'm going to take it to be equals to what? 2 pi, meaning distance from 0 here, we have 0, then we move the whole way to 2 pi. Okay. Now that we've established this, we can now go ahead and just expand on this idea. So if I have area under the curve, we know that from 0 to pi, we have a sine wave. So when we want to get an area for this, we use integration. So we can integrate from 0 to pi. So I have integration from 0 to pi here. Since this signal or this wave here is a sine wave, so I can write the maximum voltage sine theta. Then we bring the theta here. Now we have 0 from pi to 2 pi. Here you can see that is 0, so we can just add plus 0 here. Then we have this divided by 2 pi. So this is how you get the answer. From here we can now go ahead and simplify, right? So I can bring 1 over 2 pi, and then we have 0 to pi, maximum voltage sine theta, the theta. So we integrate sine theta. When you integrate sine theta, what do we get? We get minus cos theta. So this becomes, we put all maximum voltage is a constant, we can put it outside. The same with the negative from the cos, right? From cos theta, we can put it outside, then we can just have cos theta here. Then the limit, we bring the limit, which is 0 to pi. So we have this, we continue. So this is just minus Vm over 2 pi. So here will be what? Upper limit minus lower limit. So upper limit, that will be cos theta minus cos 0. So we have cos theta, sorry, cos pi rather. We have cos pi here is what? Minus 1, and then cos 0 is 1. So this way goes to minus 2 times minus 1, you get 2 Vm, maximum voltage, over 2. So that 2 and 2 is going to cancel, then we have maximum voltage over pi. Okay, so this is how we calculate the average voltage. So the average voltage for half-wave rectification is going to be equals to maximum voltage over pi. So we can put voltage over pi. So we have this. That's the final answer. See you in the next video. Bye bye.